Okay, since this question was posted under the topic of geometry, it might be a little advanced for the poster, but I thought I'd give a specific example so you could see what's happening. So let's say we have 3 points in space, P, Q, and R. There they are, red, blue, and green. And we want the equation of the plane that contains those 3 points. Now, for the equation of a line in a plane, you need a point and the slope of the line between any 2 points on that line. In 3D, you need a point and what's called a normal vector. So what we do is we take, this is actually point P here, and we determine 2 vectors that have to lie in the plane. So this is like Q and R. So vector PQ, P is the initial point, Q is the terminal point. So if we take 5 minus 6, we get -1, -4 minus 3, -1. So there's the position vector for vector PQ. And similarly for vector PR. Now, a vector that is perpendicular or orthogonal to these 2 vectors is what we need to write the equation of the plane that passes through those 3 points. Here's what the normal vector looks like with 2 different perspectives. And here's actually the position vector for the normal vector starting at the origin. But there are the coordinates of the normal vector right there. How do you determine that? Well, one way to do it is to use this little trick here where you kind of set up a 3x3 determinant with I, J, and K. Here are the components of each of those 2 vectors, PQ and PR, and you kind of evaluate this vector by, this determinant by expansion by minors. So like it's going to be for this first component, we're going to kind of picture crossing out these and evaluating this 2x2 determinant. -1 times -1 is 1. 1 minus 0 times -1 is still 1 minus 0. That's where this 1 comes from. And for J, I'll go to red. We kind of cross out those and evaluate the 2x2 determinant containing these numbers. And remember, this is in the first row, second column. So the sign of that term is negative. But that evaluates to 1 inside this parentheses. And finally, for K, we get a -2 because we're crossing out those and evaluating 1, -1, 3, -1. We get a -2. So that's how we get the coordinates of that normal vector. You have that. To write the equation of the plane, we use these numbers. That's the normal vector. Here's the point. Well, you can use any one of these points. I used P. So it's 1 times x minus this 6 minus 1 times the quantity y minus a -3 or y plus 3. And finally, -2 times the quantity z minus 1 equals 0. If you remove the parentheses, combine similar terms, there's the equation of the plane right there. And there's what it looks like. That blue plane comes from this equation right here, and it's containing these 2 vectors and the 3 points. And by the way, if you want to prove that these 2 vectors are indeed perpendicular to this normal vector, you can take the dot product of n and PQ, and if you get a result of 0, the vectors are perpendicular. And you can see in both cases, the normal vector is perpendicular to each of these vectors. Okay, there you go. Hope I gave you a picture of what's going on. If you have any questions, post a comment.